Let's try that again. Welcome back. No sound coming through this time. Okay, guys, so we're going to move on to autonomic nervous system, which is part of the peripheral nervous system. Yes? Okay, part of the peripheral nervous system. There's two major subdivisions, sympathetic and parasympathetic. We're going to go through both of them. Now, this is one of those lectures that gets confusing, okay? And it builds. So if we get to a step that you have a question, even though I'm taping, by all means, ask the question, okay? So I have just a brief little introductory tape for you guys to watch, okay? This gets a little bit deeper than we go. It's still a good song, so I'm going to let it play. All right, that's moving into things that we're not going to get into. So I'm going to stop it at this point. Fun little thing. Once again, a great way to review some of this material. Another way to look at it. Okay, so autonomic nervous system. So the general gist with autonomic nervous system is it's two subdivisions, isn't it? What does parasympathetic do? What does parasympathetic do? Is it going to slow down physiological processes such as heart rate and breathing? Yep. And then sympathetic does what? Increases it. And our autonomic nervous system is constantly trying to balance itself between these two systems, parasympathetic and sympathetic. Because you also don't want to be way off in one direction, right? If you're really into parasympathetic, your heart rate would be too what? Low. Your blood pressure would be too low, excuse me. If you're all the way into sympathetic, the heart's going to be beating too hard and too fast for too long, and other things can happen that wear down the body. So it's a nice balance between them. Here is how the nerves come out. I have this in the notes. The sympathetic nervous system, this is in the notes. You don't need to take notes. I just want to give you a general beginner's look. Okay, couple of things. Sympathetic is going to come out of the thoracic and the upper lumbar spine. Okay. Parasympathetic is going to come out of the base of the cranium and the sacrum. Why? That's just because that's where those nerves come from. Sympathetic is also going to go to all of the tissues in the body. Parasympathetic is going to go to a lot fewer tissues in the body. Okay, so just a couple introductories as to the actual anatomy of it. Now, you could see right where the thoracic and the lumbar spine are, there are nerves coming right out into ganglia. Do you remember what ganglia are? We talked about those briefly. Ganglia are going to be a collection of cell bodies. So sympathetic nerves send a shoot out. They'll actually talk to another cell body in those ganglia and then send a nerve out into the periphery or out into the tissues. Okay? Parasympathetic will send nerves out to a ganglia that's closer to the organ. We're going to go through all this, okay? And then it'll send a second nerve out. So each one of these systems are going to have how many nerves? 2. Okay, they each have 2, but they're structured differently. I'll walk you through it, okay? Autonomic nervous system consists of motor neurons that are going to go to anything that's automatic. Okay, I have some of the breakdown here. Smooth muscle is going to be automatic, isn't it? Where are we going to find smooth muscle? We're going to find it around hollow organs, around blood vessels, okay? Around structures that will just control themselves. Cardiac muscle is going to be found obviously in the heart that regulates itself. And we're constantly making these little adjustments via subconscious control. Can you control your heart consciously? What if you get really stressed out though, right? You get really stressed out and that sympathetic nervous system can increase it. So indirectly our thoughts can affect this, but it's not direct, okay? So sympathetic, parasympathetic, most organs are going to have both sympathetic and parasympathetic. Let me tell you the exception. The exception is blood vessels, okay? Blood vessels are only going to have sympathetic innervation. Blood vessels are only going to have sympathetic innervation. So let me ask you this. If you're in a stressful situation, do you want your blood pressure to go up or down? Do you want to pump blood harder and faster through the body, do you think, in a stressful situation? Absolutely, you do, because you want to move blood quicker out to the tissues, especially the skeletal muscles, so they could get more what? Oxygen and glucose. So sympathetic nerves, guys, are going to cause a little bit of a constriction in all the blood vessels. Okay? If they're turned off, what do the blood vessels do then? Dilate or open. Okay? So sympathetic nervous system are the only nerves that go to blood vessels. When they are triggered, they cause a slight constriction of the blood vessels. And if you decrease the diameter of a tube, what do you do to the pressure of the fluid in it? Increase it. You're going to move that blood quicker out to the tissues. Okay? Sympathetic nervous system turns off, and what do the blood vessels then do? Open up. Okay? So that's the one big exception, is blood vessels are only innervated by sympathetic nervous system. Parasympathetic is going to be, if you were to imagine you were home, relaxing, you got a cup of coffee, reading a book, okay? During that resting phase, you are resting, relaxing, your body actually repairs during this time, okay? And this is going to be the time during which we will also have more defecation and diuresis. What does that mean? Defecation means number 2, diuresis means number 1. So during parasympathetic stimulation, that is when we defecate, that is when we go to the bathroom, okay? It is also when we digest. I have this further in the notes. So when you think of parasympathetic, there are 3 Ds that are associated with it. Digestion, diuresis, defecation, okay? This is why they tell you not to swim after doing what? Eating, okay? They tell you not to swim after eating. Because when you swim, you exercise, you stimulate the sympathetic nervous system, and you take that stimulation away from the gut and put it to the skeletal muscles, and you don't digest as well. Okay, so digestion is going to happen during parasympathetic. Okay, blood pressure will be low, heart rate will be low, respiration will be low. GI intensity is obviously high, pupils are constricted, and lenses accommodate for close vision. Okay, and here's those nerves coming out of, this is a better picture, you can see them coming out of the cranium. Now I want you to just take a minute and look at the ganglia. Okay, are the ganglia close to the spine or far away from the spine? Are they right next to the spinal cord or away from it? Away. We've got two nerves in both the parasympathetic and the sympathetic nervous system with a ganglia in between those nerves. In parasympathetic, those ganglia are close to the organs. Okay, they're close to the organs. And this is a great picture to show that. Okay. Now, role of sympathetic division. So this is going to be our fight or flight. This is going to be the bear comes in the back of the room, right? And you're going to decide whether you are going to fight or flight. Okay. It's going to shunt blood vessel to skeletal muscles. What's going to happen to heart rate, ventilation, and blood pressure? They all go up, right? Preparing the body to send the blood out to that tissues. What are bronchioles? Bronchioles are the tubes that go to the lungs. So they're going to dilate, which means they open so you can do what better? Breathe better, okay? And liver's going to release glucose so we can get more what? Energy, okay? So the body is preparing itself for a long fight, isn't it? Okay, it's preparing itself for a long fight. Now, if we look at sympathetic, so this is thoracic and part of the lumbar spine. Do you see those little yellow expansions? Can you guys see that? Or are they too small? What are those little yellow expansions that we're looking at? Those are ganglia. Very good. In the sympathetic nervous system, which is what we're looking at here, are they ganglia next to the spine or farther away from the spine? Perfect. Next to. So sympathetic is going to have a short first nerve, then the ganglia, and then a longer second nerve. Okay? And that's called the sympathetic trunk. Now this is going to be critically important because if people have surgery near this area, this can be nicked. That would be kind of a bad thing, wouldn't it? One of the major signs and symptoms that you'll see is a change in the ability for those blood vessels to contract or release appropriately, okay? And they can get cold white hands. So that's one thing to know about that, sympathetic trunk, okay? So, peripheral nervous system. These are controlled by the central nervous system, right? Okay, they're controlled by the central nervous system. Okay. Maintain homeostasis, smooth muscle, cardiac, and also glands. Two main divisions. So, sympathetic, parasympathetic. A lot of this we talked about. Here's some more specifics. So, sympathetic is going to be fight or flight. Parasympathetic's eating chips and beer. Okay, you're relaxing, digesting, diuresis, defecation. Now, the actual numbers for sympathetic are going to be thoracolumbar T. That should be 1 to L2. It shouldn't be T12. I don't know what happened there. I had a typo. See where it says T12? That should be T1, okay, to L2. Guys, what is a preganglionic fiber or nerve going to be when we're talking about these two subdivisions? What is a preganglionic? Well, what does the definition tell you? Before the ganglia. So if we're looking at the sympathetic nervous system, it's going to be that short little nerve that's going out to those ganglia that are right next to the spine. If we're looking at parasympathetic, it's going to be the ganglia that's closer to the organ, so it's further away from the spine. Okay, now that I've explained that, you tell me, in the sympathetic nervous system, are we going to have a short preganglionic fiber or long? In the sympathetic nervous system. Is it going to be short or long? Short, right? Because it comes out of the cord and the ganglia is right next to the spinal cord or the spinal column. So the postganglionic fiber is going to be what? Long. Okay, postganglionic fiber is going to be long. As opposed, does that not make sense? Yeah? How about then tell me parasympathetic? The preganglionic fiber in parasympathetic, is that going to be short or long? Long, there we go. And the postganglionic fiber will be short. Just because it's the placement of that ganglia that makes a difference. Okay, does that make sense? Okay, good. So we looked at those ganglia, we know where those are located. Multiple postganglionic fibers in sympathetic because it innervates a lot more tissues in the body. Okay, parasympathetic is going to have fewer. Now, parasympathetic is going to come from craniosacral. The cranial nerves that feed it are going to be 3, 7, 9, and 10. Okay, the ones that we just learned. So we're going to have little fibers that come from those cranial nerves that are going to provide the autonomic function to our bodies. Cranial nerve 3, we just tested that in lab. For those of you who have had lab, if you have Monday lab, just ignore this. When you shine the pen light in somebody's eye, optic nerve will sense that light coming in, and guess what oculomotor nerve does? Constricts the pupil. Those are autonomic fibers that come from cranial nerve 3 to provide that function. Okay? So not only do they have regular oculomotor will move the eye, right? That has controlled or a way that we can control it. It also has autonomic functions as well. Okay? So 3, 7, 9, and 10, and then sacral nerves 2, 3, and 4. Okay? I'm sorry, just let me pull these all in. I can't get this off for some reason. So some easy ways to remember what sympathetic does and what tell me when I'm done with this left column, or I have to redo this. I'm done? Yeah. Okay, good. So sympathetic versus parasympathetic, the way that you can remember what they do is sympathetic is all ease. Exercise. When you exercise, your sympathetic nervous system kicks in. Ergo, the don't swim after eating, right? Because you're going to focus on skeletal muscles as opposed to sending blood to the digestive tract. Exercise and embarrassment. All of these will stimulate that sympathetic nervous system. As opposed to parasympathetic is going to be all D's. Digestion, diuresis, defecation. Okay? Diuresis is urination, defecation is number 2. Okay? So all those happen during parasympathetic and other things as well, but these are just a good way to remember in general. Okay? They balance each other. Obviously, you can't be off too much in one direction. For example, if you were constantly, people are doing research on people who are constantly under stress, constantly in what's called sympathetic facilitation. Well, guess what you release when you're in sympathetic facilitation? You release what are called corticosteroids. Okay? We know what steroids are, right? They build up muscle, but a lot of physicians use corticosteroids as injections as well, right, to decrease inflammation. Prolonged release of that corticosteroids actually can start to eat away at your tissues of your body. So you don't want to constantly be super stressed out. You've got to bring it in balance with that parasympathetic, okay? So the neurotransmitters that we're going to look at with sympathetic, well, there's 2, but just as an introduction, it's norepinephrine and epinephrine. Sympathetic is going to increase blood sugar. Why on earth would it increase blood sugar? Absolutely, very good. It's going to give you more energy. It's going to release those stored forms of glucose so you have more energy to go fight that bear or whatever it is. Okay? Go exercise. Eyes will dilate in sympathetic. I always remembered that because I thought, well, if I'm in trouble, I really want to be able to see well, right? So dilates will open, or pupils will open. Obviously, the rest is pretty important. No, the one thing, though, I think I touched upon, but not thoroughly yet, is blood supply is going to go to the skeletal muscles. Okay? Once again, it's going to bring oxygen and glucose to the skeletal muscles. so they can function and provide energy to fight or flight. Now, parasympathetic is going to be energy conservation. It's also important because it's a period when your body will rejuvenate itself. That's why it's so important to sleep. When you sleep, it's a period when your body is regenerating its tissues. Okay, so it's very important to rest. Decreased heart rate, we got that. SLUT is an acronym to remember some of the things that happen. So salivation, lacrimation, urination, defecation. Okay. Any questions so far? No? Okay. How do we get there? So craniosacral and thoracolumbar. We talked about that, and we talked about the two parts of the neuron, preganglionic and postganglionic. Here's just a little picture. I'm not sure if this will help you or not. So we have two nerves, okay? You have the central nervous system. You're going to have a cell body that's going to send an axon down, and it'll leave the cord and either form that short preganglionic fiber or axon for the sympathetic or the long one for the parasympathetic. It'll synapse in the cell body, which is in the ganglia, and then it sends an axon out to the receptor, whatever that receptor may be. And of course, there's a million receptors, right? Okay, throughout the body. Oh yeah, I've added stuff to this lecture, by the way, if you're not seeing some of this. But I uploaded the new lecture online, the new PowerPoints, okay? So where are we going? So sympathetic is going to be to more areas of the body. Okay, parasympathetic is going to be fewer. I gave you a list of some specifics. Kidney, adrenal glands, sweat glands, blood vessels, erector pili are some examples. But sympathetic is going to go to most of the organs of the body, okay? Now you can see, I think this is really good to show a couple things, to show those ganglia, and you can see the shorter preganglionic fiber in the sympathetic and the longer one leaving, and vice versa in the parasympathetic, okay? It also shows that even though we've got a lot of the cranial fibers going to the brain, I want to show you, see that one that comes down, that long purple one? Can anybody guess what cranial nerve that is? Its name actually means the wanderer. One of the derivations is vagabond. Vagus. Vagus is nicknamed the wanderer. Can you see now why? That one little nerve comes out of the cranium, and it provides parasympathetic innervation to most of the organs in the chest cavity and the abdominal cavity. And that one little nerve comes down and sends offshoots to all these organs, okay? It is the primary, until you get into the pelvic basin, the primary parasympathetic nerve to the chest and the abdominal region, the ventral cavity, okay? Vagus, cranial nerve 10. Okay. That vagus will cover everything down through the abdominal cavity when you get into the pelvic basin. So bladder and genitals will be S2, 3, and 4. Okay, S2, 3, and 4. And then you could see sympathetic is going to branch off, you know, about the level the ganglia is. It's going to send some offshoots to be a little bit closer, but it's the ganglia are closer, or the nerves are closer. Okay. So we got this, cranial nerve 10, vagus known as the wanderer, okay? The way that it actually functions, though, is it's going to send shoots down and it forms what are called plexuses. Now, what is a plexus again? A collection or network of nerves. So we have this network of nerves, these plexuses, that are formed on the front part of the aorta from the vagus. There's going to be cardiac, pulmonary, and celiac. So cardiac is going to send parasympathetic where? Heart. Okay? Pulmonary is going to send nerves where? What is pulmonary reference? Lungs. Very good. Celiac refers to abdominal organs, GI organs. Okay? So we have a network that's going to be on the front of the aorta that gets its fibers from the vagus. Okay. It's going to form three major subdivisions: cardiac, pulmonary, and celiac. Okay. And of course, these will all be parasympathetic. And you can see there's the different subdivisions. I think that only has celiac plexus. Oh, I thought I had put another picture in there. Cardiac, pulmonary, celiac. Oh no, they're all there. Okay. And you can see a picture, if that helps you, of that cardiac, the pulmonary, and that celiac plexus. Okay. And that celiac plexus is going to go to everything in the abdomen: liver, stomach, pancreas, etc. Okay, all the way through the GI tract. Okay. Let's see. I know that this is, I think I'm just about halfway through. It's kind of a short lecture. Let me fire this up. If you need a cup of coffee or something, go right ahead. I want to check to make sure that this is videotaping. Okay.